AVS Media Demo.
This is a stopping distance problem. So from point A to point B, I ride my scooter at a constant speed. As my back tires touch point B, I apply my brakes. In this problem, I will be calculating how to find the stopping distance and the time it takes me to stop. So first, we solve for the velocity from point A to B. The equation is velocity equals distance over time. As you can see, the distance is 5 meters and the time is 1.5 seconds from point A to B. So we solve for velocity and we get 3.33 meters per second. Next, we solve for force gravity. The equation for force gravity is mass times 9.8. In order to get mass, we have to take my weight, 160 pounds, plus the scooter's weight, 7 pounds. We add them up and get 167 pounds. Then we convert that to kilograms and we get 75.75 kilograms. We plug that back into the equation and we solve for force gravity and get 742.36 newtons. Since the scooter is on the ground and not above or below the ground, force gravity equals force normal. So both force gravity and force normal are both 742.36 newtons. Next, we solve for force friction. The equation for force friction is coefficient of friction times force normal. In order to get the coefficient of friction, we go to the reference sheet. And for rubber and dry asphalt, the average coefficient of friction should be 0.65. We solve for force friction and we get 482.53 newtons. Next, we solve for acceleration. For force net, we use the force friction, so force net is 482.53 newtons, and the mass that we solved for earlier. And the acceleration should come to 6.37 meters per second. The information that we have so far are velocity initial, which is 3.33 meters per second, velocity final, which is 0 meters per second, and acceleration, which is negative 6.37 meters per second. The reason it's negative is because you slow down and you come to a stop at the end. The two things that we don't know yet are time and distance. The stopping distance and the time it takes to stop. So we solve for time using the equation velocity final equals velocity initial plus acceleration times time. We solve for time and get 0.52 seconds. Next, we use the following equation to solve for distance and we get 0.87 meters. So it takes 0.87 meters to stop once I apply the brakes at point B, and once I apply my brakes at point B, it takes 5.52 seconds to come to a complete stop.